Our next module is the fundamental module called arithmetic operators. In C, like in just about every programming language in the world, there is the ability to perform arithmetic natively within the language. And I'm talking about arithmetic such as addition, subtraction, multiplication, division, and there's actually a fifth one which you'll see in a moment. The arithmetic operators are plus, minus, asterisk, slash, percent, and they are respectively addition, subtraction, multiplication, division, and modulo. You may not know at this point what modulo is. That's alright, I'll tell you what modulo is in a moment. They are used as you might expect them to be used. Let's turn now back to our compiler to have a look at some examples. Here is the age program from chapter 2. Let's do a little bit of arithmetic operation on the age that gets entered. For example, let's find out how old someone would be if they were half your age. So what I'm going to do is I'm going to create another variable here called half, like so, int half. After they've entered the age, I will now assign a value into half, which is of course half that age, and I will do it like this: half equals, can you think what I'm going to type next? AGE slash 2. Age divided by 2, that's how you read that, which is of course half your age. And then of course you might want to change the printf saying a person half your age would be %d, and now half goes here of course. Okay, so let's see if that compiles and runs. Compile first, 0 errors, and run. Please enter your age. Alright, let's enter an age like 36. Person half your age would be 18. Of course it's working. Good. Let's run it again. This time we'll enter a different age. I'll enter the age of 23. What do you expect the answer to be? Well, I can think of three different options. I can think of 11, 12, or 11 and a half, depending on how the compiler or the C language is defined. Let's see what we actually get. 11. Now you might want it to be 11 and a half, and you might be thinking, why is it not 11 and a half? The output of 11 and a half might look like 11.5. Now 11.5 is a decimal number, and it's certainly not an integer. And as you recall, half, the variable half, is an integer, so it cannot have fractions or halves. So it's a bit odd that half can't have halves, but that's because it's an integer. So it's either got to be 11 or 12. Now you might think, well, does it round it up, or does it round it down, or does it round it to the nearest up or down? And the answer is, in C, it always rounds it down. It might sound odd, but it always rounds it down. Yes, and I suppose you've all noticed that I've just made a spelling mistake with half, so I'll just fix that. Okay. What other operations can we do? How about subtraction? How about, how many years has it been since you were 5 years old? So let's invent another variable called int years, and we'll say that years equals age minus 5. If you think about it, that's how many years ago it's going to be since you were 5. Obviously, before we can compile and run this, we need to change the output such that we have a printf statement to show what years is. So I'll just duplicate this one. Let's change this. It has been %d years since you were 5. And the last thing I need to change is half is supposed to be years. Okay, so let's compile that and test it. Compile, compiles OK, and run it. Please enter your age, 36. and it has been 31 years since you were 5. That's quite correct. Gosh, that's a long time. I have for you now some more examples of arithmetic operators in C. I've declared myself 3 integer variables, x, y and z, and I perform some arithmetic on them. X equals 9, y equals x plus 6 divided by 3, z equals x times y plus 1 plus 2 minus 3 times 4. And then I print out the answers. Okay, so x is obviously going to be 9. What do you think y is going to be? Have a think about that while we compile and run this program. Compile, working, and run. Now x equals 9, obviously. Y equals 11. Let's have a look at that. Y equals 11. Does y equal 11? Okay, it's 9 plus 6, which is 15, divided by 3. Surely 15 divided by 3 is supposed to be 5, isn't it? Is something wrong? Well, there isn't anything wrong. It's possibly our understanding of arithmetic that might be a little bit wrong. You don't believe me? Okay, I need to talk to you about precedence. Some of you may already know what precedence is when it comes to arithmetic, especially if you've been a programmer before, or even if you've used Microsoft Excel or Lotus 1-2-3 extensively. The reason that this in fact equals 11 is that the divided by happens first. In this line of code, the divided by happens before the addition. Now why is that? Well, you think about it like this. The divided by is more important than the addition, so it happens first. So the 6 divided by 3 happens first, giving a result of 2. And then the 2 is added to 9, giving 11. It does not happen the other way around. You don't add the 9 to the 6 first, and then divide the result by 3. So don't get this confused. It doesn't mean it happens in the reverse order. It doesn't mean that we start at the end of the line and move backwards across the line until we get to the equal sign. It doesn't work like that either. What it does mean is that divides always happen before pluses. So what are these precedence rules? Let's have a look at them. Okay, we're examining the precedence. The precedence looks like this. I've deliberately put the multiply, divide and modulo arithmetic above plus and minus, indicating that they are more important. Perhaps more important is the wrong term. Technically, they get executed first. So anything that's a multiply will happen before any pluses and minuses on any given line of code. So similarly, divided bys also happen before pluses and minuses, and modulos also happen before pluses and minuses. So if you see a line of code that's got mixed operators, the pluses and minuses will always get evaluated last. Now you may think to yourself, well, what if there's lots of different multiplies and divides on the same line? Will they get executed at the same time, or how does it work? And it works like this. They are executed in whatever order the compiler thinks they should be executed in. Now don't worry, that doesn't mean that you're going to get a random number coming out. As if you take a number and then multiply it by something and then divide it by something else, you get exactly the same result as if you divide it by something else and then multiply. So, I think hopefully we understand precedence now. What happens though if you actually want to have it go the other way around? If you have a plus in a line of code that you need to have executed before the multiply, what do? Well, you use brackets. Let me show you how brackets can be used. Here we are back in our program on the line of code y equals x plus 6 divided by 3, and we want the x plus 6 to happen first, so we use brackets, and here's where the brackets go. The brackets go around the two operands of the plus sign. In other words, you surround the plus with brackets. Brackets are the highest order of precedence of any operator in C. Everything in brackets is evaluated before everything outside of brackets. So clearly here the x plus 6 gets evaluated before anything else. So we get 9 plus 6, which is 15, divided by 3 we get 5. Let's just check that that works. Compiles and runs, and now y equals 5. That's correct. Notice that it's not particularly important whether you put spaces around the pluses and minuses and divides and so on. Here I've got spaces around them and here I don't, and it doesn't make any difference. You might recall from earlier in this chapter, white space is completely irrelevant to the compiler. So what about this modulo arithmetic? What is that? Do we know what it is? Have you ever seen it before? Well, you may have seen it before and just simply not known it to be something called modulo. So let's see if I can't give you an example that makes sense. Firstly, I'll just give you a standard modulo example. X equals, let's say, 15 modulo 6. Okay, now if I move that line up above the printf, then hopefully the x that's printed out will be that x right there. Let's try that. Does anyone know what the answer is going to be? 15 modulo 6. Let's try it. Compiles, runs. The answer is 3. 3. Okay, why is it 3? Does anybody know? Okay, you probably don't. For those that don't, I'll explain what modulo is. Modulo is the remainder after a division has taken place. So, this is how you think about it. If you were to divide 15 by 6, you'd get the answer 2. Well, there are no fractions. Remember that from before? It always rounds down, so you get the result 2, not 2.5 or anything like that. You get the result 2. And what's left over? Is there a remainder in this division calculation? 15 divided by 6 is 2, remainder 3. Does that sound right? Okay, notice that remainder 3. So x gets the set to the remainder value. Gets set to the modulo. 15 modulo 6 is 3. It's the remainder. That might sound completely odd to you and not particularly useful for anything. Have you ever seen modulo arithmetic before? Well, let me ask you this. If it's 10 o'clock in the morning and then I ask you, what time is it 5 hours later? What's the answer? Well, it's pretty simple. The answer is 3. So think about that. 10 plus 5 equals 3. How can that be? 10 plus 5 equals 3. And you think, well, of course, there's hours involved and there's another 12 hours, and yes, we know all that. Okay, what's actually going on here is that modulo arithmetic is at work. The hours are added together and then the result is presented modulo 12. Let me show you, using source code, exactly what I just said. It's 10 plus 5 modulo 12. So, let me explain that. It's 10 in the morning, you add 5 hours, and what time is it? Well, it's 3 in the afternoon. And the reason you'll get 3 is because we do it modulo 12. Let's check that. And you get 3 as before. So let's just have a couple more examples. If I said 10 and what time is it 12 hours later? After 10 in the morning, well, it's obviously 10 in the evening. Let's check that. Yes, 10 in the evening. Okay, you might be getting the idea. What about 10 plus 35? Well, think about it. 35 is actually one short of 36. So 36 hours after 10 o'clock in the morning is going to be 10 o'clock in the evening the next day. So if it's not 36, if it's 35, then it's going to be 9 o'clock in the evening the next day. Let's check that. And yes, we've got 9 o'clock in the evening. Well, it doesn't specify in the evening, but it is certainly 9 o'clock. We're using a modulo 12 here, which means it's just a 12-hour clock. There's no such thing as 24 hours or AM or PM or anything like that. It's just every 12 hours it goes back to 0. So that's modulo arithmetic. It does actually come in handy, not terribly often, but every now and again. It's part of the C language, so it's necessary for me to explain it to you. Before I end this module, I'll just show you that it's actually possible to get the result of a calculation without using a variable at all. I'll do that down here, and I'll do a printf. Answer is %d \n. The answer to what? Well, how about the answer to 3 times 17? Let's try that. Okay, and run it. Answer is 51. Well, that's correct. That's what 3 times 17 is. Nowhere there did I use a variable. X, Y, and Z are not used. So if that's all I was trying to find out, the answer to 3 times 17, I don't need a variable at all. I want you to see that it is possible to do a calculation inside a printf if you want to. If it makes sense to do that and it's clear enough in your program, then it's recommended because you save a little bit of memory by not having to declare a variable. Obviously you also save a little bit of processing time, not to mention coding time. Okay, that concludes the lesson on arithmetic.